Hello, welcome back to this series. And in this session, for those who are watching this for the first time, this is a small series that I'm trying to learn more about systems programming, where I implement small projects related to systems in C++. This video, I'll be trying implementing an event loop. It's a it's common concurrency a tool to implement concurrency, and you can usually find it in frameworks like Node.js or anywhere you would see asynchronous operations or asynchronous contract constructs um, working. And I'll be heavily referring to uh, the original Node.js event loop, and we'll try to implement like a simpler version of it. Let's start. I have Node.js uses something called libuv, which is a cross-platform asynchronous I/O library in C, and it was written for Node.js, and then it also is kind of a shared package that anyone can use to implement asynchronous operations. But we'll take design ideas from libuv and then just implement the event loop part of this whole library. Essentially, what libuv provides is it provides like certain API to um, access IO operations, different kinds of IO operations like file, DNS, TCP, network IO, etc. Um, Using asynchronous constructs, and at the base of it, at the core of it, is the IO loop, which is also called as the event loop. Simply put, it's a infinite loop. I mean, it's not really infinite, but it's a loop that kind of keeps checking for events, and when it sees events are ready, it kind of hands it back to the to the program that called or requested this event. Like, I think I'll try to implement a very simple example of this. Like the most simple one that I can think of is input to the stdio. So think of something like a function that wants to read the input from the keyboard. The function can request it to the event loop, but the event loop should not block other processing. So if there are other tasks, it should execute the other tasks and not block on the keyboard input. And whenever the keyboard input is available, it should just then kind of continue the function that was blocked. Yeah, let's see. It would be interesting to implement, and I'm not sure how if I can do it like in under 30 minutes. So I'll try to implement as much as I can, and then maybe do a second video again. So to the core of it, I think it's very similar to the task scheduler from the last videos. And I also recently got to know that header files for C++ can have this HPP extension. It's not unnecessary. .h also works, but it's just practice and convention, I guess. But yeah, as usual, I'll try to define the public API, and we'll create a class for this. So we have a class event loop, and it will have some private constructs. As usual, there would be some sort of a queue, which will be a vector. And I would take the job class from the previous example, from the previous videos, to just reuse it here. And actually, I don't want priority here, so I would just include IO stream and include vector as well. And this would be a vector of job pointers. It would be a simple queue. We don't want the priority here. I'll just remove this. Keep it simple. Yeah. Okay. So we have a job. Yeah, let's not call it job. Let's call it task. It's a bit better when we are talking about event loop, because essentially, um, yeah, I mean, you would enqueue tasks and these would be executed. I mean, the same, but just for the sake of familiar words. So event loop will have a constructor. We don't need any arguments as such. And then we'll have a scheduled method, which will take in a job point. Sorry, not a job, but a task pointer. And then it will schedule it. Now, I'm thinking there has to be a way. Let's say when someone schedules a task which which requests an IO operation, how do we facilitate this? So let's take an example where we have a task where we want to request the input from the keyboard. Now, the simplest way is, I think, in C++ is to do stdio keyboard input. Scanf is like the easiest. I think I can do C in input. Okay. But C in blocks here. So, okay. Let's see. Let's try to implement this first and then come back here. So let's include event loop.h and then task we have task and the public task. Okay. So wait, how do I implement the constructor? Okay, job. Okay. Okay. Yeah. This is so take a string name, and what we take a void function, and then we save it to name is equal to name and is equal to fn Save it. Okay, and then okay, yeah. So here we might have to change something. Um, so when we try to execute the function, we would want to um, so we want to kind of give some control and then let we want to kind of schedule some event. So I was checking here the way event loop kind of runs. It goes over all these, but let's say specifically for IO operations, it uses different system calls on different platforms. So on macOS, it uses something called K event, oh sorry, KQ. So this system call provides a generic method of notifying the user when an event happens based on the results of small pieces of kernel code. Filter is executed upon the initial registration of K event to detect whether pre-existing condition is present. Um, so the way this works is so you create a K event, then you create a K queue, and then uh, you attach the event to the K queue, and then you sleep. Okay. So the difference in our implementation would be that this loop is would be the event loop, the global loop, and we will not wait individually on the event. So we would have to somehow give back the control of this thing to the event loop. So essentially, when we attach and then event. Okay, okay. So event is the one that we want to monitor, and T event is the one that is triggered, and it will be filled when something happens. T event dot flags. Okay. Okay. Let's see what we would have to do here. KQ. So I think it would be nice to pass a K event. Okay, let's first try to include this event rich. Okay, and so what I could do is when I'm um so I could run a hydration call pending callbacks, run check handles. So I could run the method. It could it could return event that I could monitor. It could return an event that I could monitor. Okay, the constraint here is that event loop should only be like there sh- so this is all happening in a single thread. I mean, at least that's the constraint with libuv. So there is one event loop per thread. So we want to do all the waiting together. Event. Okay, Q and let's try to break this down a bit. So um, schedule the class. Let's try to implement like the rest of the things into that. Um, Incompatible. Why? Okay. I mean, okay. Let's try to for now. Let's try to just say that we call this, and let's try to go the other way around. Let's try to define a job that actually does this. Okay, now for now it's like the simple scheduling thing that is going on. Let me try to clear my okay. Try to minimize this, remove this, include event loop. Okay, now let's try to, I'll also minimize this. So now we have something like read keyboard input. This is a work. And then here, what we do is um, Okay. How do I say that I want it to be the K event is called keyboard input. Mm-hmm. Do I really need K event? Let me do something like I cannot somehow I need to kind of loop over or kind of poll whether this event has occurred. So without, I don't think there's any other way. Hmm. Epoll Mac. KQ. Okay. Let me try to implement this simple example where let me just copy this over here. Go to monitor and the event, and then I create a open arc one, nothing read only. Okay. There's a KQ and the return value, and then I create a KQ. Then first I check KQ is
It's time for bed.
Oops, that was my alarm. That's my Alexa speaking. Okay, and then initialize K event structure. Here is EV set. What does this mean? Takes the file descriptor as the identifier and the events to watch for in FF flags and returns when one or more requested events occur on the descriptor. Okay, let's do a simpler example. Instead of keyboard input, read file file event, something like this. What can we do? Close right, extend, regular file, the file descriptor, file reference whether has its attribute changed, file descriptor referencing was opened. Right, okay, yeah, let's do the right thing. It's actually very similar to what this is doing here. So I'll just copy this, read file. Wait for and we'll say read file write. Essentially, we want to wait for when the file write happens. And want to do FD. File descriptor is probably like a file. Let's just have a simple file. Okay, I think we need to include some. What library file should I include? stdio, I think, yeah. Oh, no. Okay. F control. Okay, FC. Okay. File type cannot be assigned. So this should be FD open, argv. Okay. Let's just open it directly with open. Okay, and then now here attach event. Okay, so what we are doing here is kq k event in changes, how many changes do you want to watch? K event, the list, in events, and const. Okay, let's see what K event has. Okay, and okay, let's. Just some hygiene checks and failed to attach K event. Okay, so now we have attached the event, and now we want to poll, right? So this thing, KQ, K event. Okay, so now I understand a bit. So what we could do is we could actually pass pointer to KQ and T event already from outside. In here, we just call the attach event, and the monitoring also happens outside. So it just creates this event and then it returns. Yeah, something like this. So mhm. So when we try to check, we only need the KQ instance because it's the queue and we'll get notified, right? Okay. Yeah. So let's try to do this here. So instead of um okay, so it's just a descriptor. Okay. So we have KQ, and when we create the event loop, we initialize KQ to a new queue essentially. And when we um, so when we execute, we pass a KQ, which we send down. Yeah, let's fix a bunch of things. So this would be int, and this would be int. Execute will take int, and that's it. Yeah. Now when we schedule this, it should take in this. Okay, so scheduling still happens on a different thread. We use like a I will use a separate thread for the event loop. Okay. So let's also do this std thread loop thread. And then when the event loop is created, loop thread is initialized to std thread. What would you call? Okay. So this is our function where we kind of go around the loop. We look for new tasks and we execute them. We then also check for events on the queue. We come back and then we execute. Okay, so let's try. Event. Okay, I want to not stop for it. So I think one of the ideas is to use a timeout, but I want to check if there is a better way. Guess okay, queue. Okay, anyway, let's We would also want to have mutex for the queue. And then just lock it here. Queue the size is greater than 0. Then we take out a task is queue.front, and then we do queue.pop. No, queue.pop. Okay. What did I use for my scheduler? Was it a queue or a... Actually, it was a queue. So I can just use a queue here. Instead of a vector, it could be a queue. Iterators are great. I mean, like the API changes very slightly when things are iterable. Okay. We remove the task and then we try to execute it with something like this, but then we pass KQ. Yeah. Now that I understand correctly, this will currently block on the task. And if we schedule one more thing, then it will block on it. Let's try. Void run event loop tests. And what I'll do here is create a task one. Actually, I can just remove this once I accept KQ from here. So task should take enough a name and a function. Um, right, and I do something like read. Okay. And I create another task with a simple. Maybe I'll just create this as a lambda. Okay, I cannot pass a lambda. It has to be a function pointer. Void simple task int kq. I don't want to use it, so I would just do cout simple task done and yeah, and I'll just pass it here. Okay, so now I want to schedule these two tasks. And then obviously I want to create my event loop and then do something like loop.schedule. Take task 1 and then I take task 2. Okay. So I just want to check if this even compiles. Let's put it here. Okay. Log guard needs a template argument. Guard of type mutex. Okay, I'll just try to remove all of this for now. Okay. So the file compiles. Let's try to run it. Okay. So it failed. It aborted. Now I want to see why. Um, Sigaboard. Okay. Event loop, run event loop tests. Okay. So creating an event loop was a problem. Okay, I just wanted to check if the queue, the thread is the problem. Okay, okay. So creating the thread is the problem. So loop thread. Let me quickly check what I do in the scheduler here. Thread this. Okay. I mean, the syntax is correct. It's S3 thread, and then I assign it to loop thread. Go around the loop. Is this the problem? Let's try to narrow it down. Okay, so just creating the thread is a problem. Loop thread. Let's try to see where we define this. Just want to quickly check how I do this here, a thread, and then okay, I mean it's correct. So loop thread is here, and I okay, let me check. Synchronous. I mean, I could also do this maybe instead of a lambda. Mm, okay, I'm a bit confused here. Why isn't it working? While the Alexa stop. So the structure of essay is called while the thread is joinable, is reterminate is called. Okay. You must keep the thread object as a member class or store it somewhere else or detach the thread. I mean, it is. Maybe. I think. No, wait. Okay, let me try to use a different. Uh, okay. What's wrong? What's wrong? What's wrong? Probably I need to join it. So let me try to. So okay, I think yeah, I need to join this. Wait, I will just. Okay. Okay, I'll just check this stuff and be back in a minute. It was just this missing loop dot wait. So I implemented the wait function, but I need to actually call it in the main function. So now the program runs. I can see the simple task completed. And now let's say if I write, okay, there's no event because I'm not really watching for it, right? So somewhere outside, so now the event has been registered, but I'm not reading it anywhere. So I need to now figure out where do I read this. So this is the while loop. Okay, so there is an execute, and here actually I could read this. So int ret. Here I figure out. Yeah, actually Claude, help me in here. Um, k event. I call this method here. I call this function k event. Something like this. I need to create a t event first. But I think I'll specify a timeout. Time spec. How do I define time spec? So timeout would be a pointer to a time spec event list and events. Okay. Yeah. I just want to check now what happens when I do not pass any timeout. So I would believe that it would um, yeah, it would just simply wait there. Let's see. Okay, I don't want to close it yet, but let's say I want this. If return is this, if return is greater than 0, then t event dot flags. If something was returned, t event dot flags. If ret is greater than 0, okay. Okay. So if timeout to effect a poll, the timeout argument should be a non-null. Okay. So how do I create a time spec? Um, I need time rich. Okay. Seconds and nanoseconds. This is the algorithm for conversion. Okay. 1 second has 1,000 milliseconds. 1 millisecond has 1,000 microseconds. Okay, whatever. Then time spec. Just wait for 1 second. I believe so. Yeah. Now when I write something, yes. So I get the event return to file, and even if now let's do this thing where let's do a simple task and then maybe sleep for a bit. Okay. So we can see, so if I reduce this, the, let me do something like, okay. And then ts.tv and sec. So nanoseconds, I want to wait for any power 6. That's still like should be pretty fast. I mean, yeah. Maybe I'll wait for 7. This is actually 100 milliseconds, I would say. Yeah. And then I will remove the sprint, and it should kind of look similar to, yeah. So we kind of implemented a event loop because without multiple threads, so it's single thread which is also executing tasks, but it is also polling for uh, IO events. And with I can still think of making this better, but I mean I think I'll close this video for now. But right now we are waiting on this event here. But if you think of, let's say, something like a JavaScript program, um, the program kind of pauses at a certain point, the IO event completes, and then control is given back to the program at that particular point of time. So I think it's possible because of like the concept of callbacks, right? Maybe something of that sort can be here. So something like in the job, I could do something like um, I could pass a function pointer, for example, which is Oh, I forgot how do I write. Yeah. So I could do something like this. So read file write also gets another argument saying callback, and the callback can be run. So the function can set a callback value, and this callback will be run once the event completes. So something like I can set. Let me write a simple callback. Void callback 1, and this would be something like finally something written to the file. And then I would do something like callback is equal to callback 1. I will update the definition here for this, and it could receive okay. And okay, and here we can create a callback pointer. So something like um, okay, once it is written, you can call it the callback. For this, I can just ignore the callback. Okay, I now have a minimal. Let's see if it compiles. It does. So I have a minimal kind of representation of how the JavaScript event loop works. So I've introduced this concept of callbacks. Callbacks are these functions that will be run after a certain event occurs, and the task, any task is given this empty pointer, and then inside the task it can set a custom callback. Let's see if this actually works. Okay, I have this. I'll write something. Okay, so there's a bus error. Probably some, yeah, probably I'm not kind of writing it correctly. Okay, maybe address that does not satisfy its alignment requirements. Okay. Use a lambda here. Okay. 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 Maybe I could do something like return out. Okay. I think I should stop my rabbit hole here, exploration here. I'll try this later, and if I find some solution, maybe I'll create a small video. But that's it. I think we did like a minimal representation of a event loop, and I think it was fun, especially learning about K event and how asynchronous event polling can be done. Um, that's it. Thanks for watching. If this turned out to be a long video, I'm not sure if I can cut anything out, but yeah, it's just a programming exploration. I did not want to create anything polished. It is fun. See you in the next one then.